A very good morning to all the students. I am Sagar Kumar, and in today's lecture we are going to discuss about elimination reaction. So we will begin with the definition of elimination reaction. So elimination reaction is a type of reaction in which a pair of group of atoms or a pair of atoms is get removed from a molecule and which leads to the formation of a unsaturated compound. This is called elimination reaction. Elimination reaction is just reverse of addition reaction. So what happens in elimination reaction? Generally we receive a unsaturated compound from a saturated compound. If we talk about the types of elimination reaction or types of elimination, we have alpha elimination. Alpha elimination will lead to formation of carbenes. In alpha elimination, the atoms which are removed from the molecule comes from the same carbon. Then we have beta elimination. In beta elimination, which we will going to discuss in detail in this lecture, in beta elimination, two groups or atoms from adjacent carbon are eliminated, which lead to formation of unsaturated organic compound. This is called beta elimination or 1,2 elimination. It is also known as 1,2 elimination. Then we have gamma elimination. In gamma elimination, the group of atoms is get removed from the first position and the third position. So this is also known as 1,3 elimination or gamma elimination, and this will lead to formation of cyclic compound. But alpha elimination and gamma elimination are not part of this lecture. In this lecture we are going to discuss about beta elimination in detail. So now we'll continue with beta elimination, or simply uh, by the point of view of our syllabus we can say elimination reaction, which is actually beta elimination. So what is beta elimination? Beta elimination, or simply we can say elimination reaction, because beta elimination mainly takes place in organic chemistry. So when two groups or atoms from adjacent carbons are eliminated with the formation of unsaturated compounds, the reaction is called elimination reaction or beta elimination or 1,2 elimination. So it can be represented as, we have a molecule here. Suppose we have this molecule, the molecule A is here, and it undergoes in elimination reaction, and in elimination this H and this X, this H and this X is get removed or eliminated, and now this compound become a unsaturated compound. So this is a typical representation of elimination reaction, or specifically beta elimination reaction or 1,2 elimination. So why we are calling it beta elimination? We are calling it beta elimination because in this reaction the hydrogen which get eliminated belongs to beta carbon. So we can see here, this is the alpha carbon which are which carrying the X or halogen, we can say, and this beta carbon has this hydrogen, that beta hydrogen. So the hydrogen is get removed from beta carbon, that's why it is called beta elimination, or because the elimination takes place from first carbon and second carbon, so we can also say it 1,2 elimination. So what are the typical examples of beta elimination reaction or elimination reaction? So there are some typical example of this reaction, as we have dehydrohallucination, dehydrohallucination of alkyl halide, dehydrohallucination of alkyl halide. The next example is dehydration of alcohols. So these two are typical examples of elimination reaction or beta elimination, the dehydrohallucination of alkyl halide or dehydration of alcohols. Now we will further continue this discussion with the example. We have an example of alkyl halide. We take an example of alkyl halide. So we have a alkyl halide, that is, suppose I have this alkyl halide. I have this alkyl halide. So for the dehydrohallucination, I have to react this alkyl halide with alcoholic KOH. So I have to react it with alcoholic KOH, C2H5OH, alcohol, and because I need a strong base, so I have to use ethanolic KOH or ethanolic NaOH. So what happens now in this reaction? This bromine is get removed in the form of bromide, and at the same time a proton is get removed from this beta carbon. So what will we have? We will have a alkene like this. We have a alkene, we have KBr, and we have water. So this is a typical dehydrohallucination of a alkyl halide, which is an example of elimination reaction. So elimination reaction have basically two types. It can take the even route or it can take the E2 route. So now we will discuss the types of elimination reaction. Before going to the types of elimination reaction, I must tell you what are the driving forces for elimination reaction. What does elimination reaction takes place? So there are two basic reasons for elimination reaction. First one is the stability of the olefin formed in this reaction, and second, it provides the relief from steric strain due to the crowding in the substrate. Suppose we have a tertiary alkyl halide. So in tertiary alkyl halide, we have a larger degree of steric strain. If this alkyl halide goes into the condition which favor the elimination reaction, it will instantly form the olefin, because in olefins the product has its stability and the steric strain is also get relieved. So these are the two driving forces for the elimination reaction. So now I come to the types of elimination reaction. So elimination reaction are basically of two types, that is the even reaction or even mechanism, we can say, and we have E2 reaction or E2 mechanism. In this lecture, we will discuss the even reaction in detail. So, what is even reaction or even mechanism? Even reaction or mechanism, I can say. So, even reaction or even mechanism, the name of this reaction is come from the fact that the rate of this reaction is only depend on the concentration of alkyl halide or only on the concentration of substrate. That's why it follows the first order kinetics. So it is known as even reaction. The name of this reaction is unimolecular elimination reaction. Unimolecular elimination reaction. So what happens in even reaction or unimolecular elimination reaction? Here we take an example of tertiary butyl bromide, tert butyl bromide. We are going to discuss the dehydrohallucination of tert butyl bromide. So what is tert butyl bromide? Tert butyl bromide is this. It is a tertiary alkyl halide. So we have tert butyl bromide. So when this tert butyl bromide undergoes the dehydrohallucination, what we have to do? We have to make a reaction between the tert butyl bromide and in a, with a strong base, that is alcoholic KOH. So what I have to do? I have to react this substrate with alcoholic KOH. And what I got here in dehydrohallucination, I got a CH3C and the CH. I got a alkene and I got ABr and water. So this is an example of dehydrohallucination of tert butyl bromide, which is a classical example of even reaction. Now we will go into the mechanism of this reaction. So if we discuss about the mechanism of this reaction, what happens here? This even reaction occurs in two steps. This is a two-step process. It is a two-step reaction or two-step mechanism. It involves two steps. The first step is formation of carbocation. Formation of carbocation. What happens in this step? This tert butyl bromide in this step, the bond between the carbon and this halogen, bond between this carbon and this halogen is get cleaved, and the electrons of this bond is taken away by this halogen. So What happens in this process? This will lead to formation of a carbocation and a nucleophile, or I can say a halide ion. So in this step, this is a slow step. It is a slow step. We got a carbocation. We have a carbocation CH3C. We have a carbocation here, and we have a nucleophile. This B, this bromide ion is a nucleophile. And what happens in this step, that the bond between the carbon and the halogen atom is get cleaved, and the electrons of this bond is taken away by halogen atom, which leads to formation of a carbocation and a nucleophile. This is a slow step, and this is the rate determining step for this reaction. In next step, what happens, that the base removed a proton from this carbocation. So in second step, in step 2, what happens? Removal of proton. Removal of proton by the base. So what happens in second step? We have our carbocation here. I can represent this CS2 like CS3 like this for the ease of representation. And here comes the base. Here comes the base, and this base attacks on this proton to get remove this proton. This base already have excess of electron, so it does not require any electron, it only needs a proton. So it simply attack on this carbocation, on the beta hydrogen, and get the proton from there. So what happens in this step? This proton get a this base get the proton removed from beta carbon, so it leads to formation of a carbon carbon double bond. So these electrons will be used in the formation of carbon carbon double bond. So here we get our alkene, and here we have this water molecule. So these are the two steps for the even reactions, in which the first step is the formation of carbocation, which is the rate determining step and slow in nature, and the second step is the removal of proton by the base. This is fast in nature. If I discuss about the kinetics of this reaction, the rate of this reaction is only dependent on the concentration of base. It means this reaction follows a first order kinetics. So rate of this reaction is dependent on concentration of substrate. It means rate is directly proportional to concentration of alkyl halide. It does not depend on the concentration of base, because the rate of reaction is only depend on the concentration of substrate. The kinetics of this reaction is first order. If I talk about the easy of dehydrohallucination of alkyl halide in even reaction, the easy of hallucination will be easy of dehydrohallucination for alkyl halides is, if I discuss about this order, then the tertiary alkyl halide favors the even reaction, then we have secondary alkyl halide, and then we have primary alkyl halide. Primary alkyl halide usually does not support even reactions, while tertiary alkyl halide and secondary alkyl halide do favor the even reaction, because the carbocation is formed in this mechanism, and the stability of carbocation formed by the tertiary alkyl halide and secondary alkyl halide is stable in nature, while the carbocation formed by the primary alkyl halide is not very stable. So primary alkyl halide does not favor this even mechanism, while tertiary alkyl halide favors even mechanism, and secondary alkyl halide also favor this mechanism. So this is all for this lecture. In next lecture we will discuss about the E2 reactions.